This is the Year 12 Specialist question from exercise 20D. We're looking at question 8. So it says let A and B be the points defined by the position of vectors A and B respectively. Find a vector resolute of A in the direction of B. So what we're trying to find is if I have a vector A and it casts a shadow on vector B, we're trying to find what this vector is, u, which has the length of the shadow but is in the same direction of B, hence it is in the direction of B. We'll call the parallel component, the perpendicular component w. So for part A, all we have to do is use our formula for a vector projection of A onto B. Before we even work that out, we need to first find our magnitude of B, which is just 1 squared plus 1 squared, which equals root 2. So we know that the unit vector of B is just 1 over root 2 by whatever B, the B vector is. So subbing into the formula, we can call that U. So U equals the dot product of A with the unit vector of B. Now we know the unit vector of B has a divided by 1 over 2, so I'll put that at the end, and we're timesing it by the unit vector of B, which is times by 1 over 2 by B. Working out the dot products, I times the coefficients together and add them. So 4 times 1 is 4, 1 times negative 1 is negative 1, 1 over 2 times 1 over 2 is just a half, and I'm left with the vector. So working that out, 4 minus 1 is 3, 3 on 2, I minus j is my vector resolute, which is parallel to B. The second part of the question asks for the component of A perpendicular to B. So we're looking at W. Now, as we can see, so from part B, we know that U plus W equals A, because A is a resultant of U plus W. So to get W, we just subtract U from A. We know what our A is. Our A is given to us. It's defined by 4i plus j. We know our U, we just worked it out, that's the vector resolute parallel. So that's 3 on 2, I minus j. 4i minus 3 on 2i plus j minus 3 on 2 is plus 3 on 2 j. So 4i minus 3 on 2i is 5 on 2i, minus 3 on 2, 1j plus 3 on 2j is plus 5 on 2j. So I can factorize that to be 5 on 2i plus j. For part C, it says shortest distance from A to the line OB. So this is our vector A. The shortest distance would be the distance from here to here. So it's the perpendicular distance. So it's essentially asking for the magnitude of W. So to get the magnitude of W, I just take the magnitude of 5 on 2i plus 5 on 2j, which equals 5 on 2 squared plus 5 on 2 squared. So equals, that's 25 over 4, so that's 50 over 4, which equals the square root of root of 50 divided by 2. Now the root of 50 is 25 on 2, so it's just 5 root 2 on 2. So that is your shortest distance, and that's how you answer the question. The key note is make sure you know which is projecting into which when you're reading the question.